So a set is a clearly defined collection of objects or items which have a common characteristics. Right? What I mean is that they basically represent a group of items or elements. Right? Usually we call them elements. So for example, the set of vowels in the English alphabet will be A, E, I, O, U, and set notation is also always written using the curly brackets. Right? So these brackets represent the words the set of. So from the example, we will say, the set of vowels. Sorry. Right? And again, the words, the set of is replaced by the curly brackets. Right? And it's A, E, I, O, and U. So that's just what the curly brackets are representing, right? And then we have to understand what are the symbols in sets. So the symbols in set notation. So the first symbol we have is this, right? This means that something is an element or a member of a set. So for example, if we say 5 E Z, where Z means the integers, right? Or Z represents integers. So we say 5 is an element of the set of integers. So 5 is an element of the set of integers. So that's what this symbol means. Now, anytime you cross out a symbol, it means it's not an element. So if you cross it out, it means it is not an element. So an example would be, let's say a half is not a member of the set of integers, because integers represent a whole number, right? So this will be read as a half is not an element of the set of integers. All right, so the next one is subset. It's like a sideways view. Sometimes they have the line underneath it, sometimes they don't. Most of the time is without the line, right? And it means a subset of. And for something to be a subset of another set, we say we have two sets. So let A and B represent two sets. And if all the elements of A are contained in B, then A is a subset of B. Oops, come on. Now what does this mean, or how do we write this? We'll say A is a subset of B. So an example would be if A represents the set 1, 2, 3, and B represents the set 1, 2, 3, 4, 5, you can see that all the elements in A are contained in the elements of B. So we can say that A is a subset of B. Now, number 4 on the list is not a subset of. So this is where none of the elements, or the elements of A are not entirely in the elements of B. So is not a subset, right? So what does it mean? This means that if we have two sets again, let's call it P and Q, all of, right? And if all of the elements of P is not in Q, then P is not a subset of Q. Now, to note that even if some elements of P are in Q, it is still not a subset. The reason for this is that all the elements have to be in the subset, not just some. Right? So an example, if P contains the elements 2, 4, 6, and Q contains the elements 1, 2, 5, 6, 7, we can see that even though we have some similar elements, it is not quite, not all the elements of P are in Q. So P is not a subset of Q. Right? So let me give some time. Right, so the fifth one on the list is union. And as a U, you're not coming down like this, right? So this is union. This is a combination of two or more sets. So an example of this is if set A contains the element 2, 4, 6, 8, and set B contains the element 1, 2, 3, 5, 7, and 9, and they ask us A union B. What does this mean? It means that we combine all the elements of A and B. Now, if you have repeated elements, for example, 2 is repeated, You do not write it twice, but you write it once. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you write the repeated element once, now the sixth one is like an upside down U. This is called intersection of two sets. Now, what does the intersection represent? The intersection represents the common elements in the set. I'll put that in red. Common elements. And spell elements with 3 E as well. So if we use the same example from above, where A is 2, 4, 6, 8, and B is 1, 2, 3, 5, 7, and 9, and they ask for us to write this set of elements A intersect B, we just locate what are the common elements. And in this case, when you have one common element, so you put it in your set, 2. Right? So the element that is common is 2. And you're not writing the others. All right, so the next one we have, I believe this is 7, right, is an empty set or a null set. Now, an empty set or a null set contains no elements. So an example would be like, okay, so if we have a universal set of the days of the week, right? So A represents days of the week. And B represents colors. Now, A intersect B would not have any elements. Why? Because one represents days of the week, Monday, Tuesday, Wednesday, and so on, and B represent color. So there would not be any common elements. So this would be an empty set or a null set. Now, the last set we have to learn about is if we have the set A prime. This prime, or this 1 here, is called the complement of a set. Now, what does it represent? It represents all the elements that do not belong to the set. So in this case, the set is A, and the prime will represent all the elements that do not belong to A. So this is another set which has all other elements that do not belong in the set A. Now, this arises from when we have universal sets. So if universal sets is numbers 1, 2, 3, dot, 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 until 10, and then we see A is the even numbers, what would be the values on A, or the elements of A? Even numbers are 2, 4, 6, 8, and 10. Therefore, the A complement set would carry all the numbers that are not in the set A. So we'll have 1, 3, 5, 7, and 9. Right, number 9, right? This n represents the number of elements in a set. Set A in this case, right? So what does this mean? So example, if set A has the elements, the days of the week, the number of elements in A would be 7, because we have 7 days in a week, right? Another example, if we have the set B, and it's 2, 4, 6, 8, 10, the number of elements in B would be 1, 2, 3, 4, 5. So it's how many elements are there, right? Number 10, equivalent sets. So A equivalent to B. Now this sign, the arrow point in both directions, means equivalent sets. Now this is not to be confused with equal sets. Equivalent sets have the same number of elements. Now, this does not mean that the elements are the same or the same value. So example, if A is A, B, C, D, and B is P, Q, R, S. So clearly the elements are different. You could still say that they're equivalent because they have the same number of elements. So the number of elements in this set A is 4, and the number of elements in the set B is also 4. So that's what equivalent sets represent. Now, equal sets, this would be number 11, I believe. Equal sets they have they are sets that are equal in all form and format. So when I mean equal elements, they have the exact same elements. So example, if A represents A, B, C, D, and B represents B, C, D, A, you can see that all the elements are the same, even though they're in different positions, they would still be the same. So A will be equal to B.